Hi, I'm Tyler Warner, and this is my AI final project. Just a quick demonstration and a quick overview of what I did. What I did was a Corsair Liquid CPU Cooler automated controller. So the a little bit of background knowledge on this. Corsair Liquid CPU Coolers usually have three modes: quiet, balance, and performance mode. Quiet mode prioritizes sound, so it just keeps everything quiet, and it puts a hard limit on the CPU fans. So even though temperatures may rise, and it may rise more than I want them to, or may get to a critical point, it will keep the fan speed low so they're quiet. Balance tries to strike a balance between quiet and having that fan speed. So yeah, and then performance tries to kick in the fans as quick as possible. So if temperature fluctuates even a little bit, then it's going to kick in the fan speed to like maximum potential. So it doesn't ever get to a point where it ever overheats. Um, so what my project does, like I said, quiet. It's nice and quiet, which I like. Although once those CPU temperatures get up a little bit, um, the processor has a tendency to heat up more than I would like, or heat up a lot more than any of the other methods. So what this does is when there aren't any moderate or vigorous processes detected or active, then it will put the CPU fan feed into quiet mode. If there are any moderate processes, then it will put into balance mode. If there are any vigorous processes, it will put into performance mode. And what it does is it classifies each and every active process as low, moderate, or vigorous as far as intensity and how much they're utilizing the CPU. So now that the brief overview is over and dealt with, you kind of have an understanding of what everything that's going on or everything that's going on. We are going to start kind of just giving you an example of how loud the fans actually get. They get pretty loud. And then we're going to go through a calibration process. So we're going to run Geekbench, which runs a whole host of other programs to kind of like put the CPU under stress, or just to kind of benchmark the CPU and benchmark the cooling systems, and you'll just kind of get a feel of how it works. So it records live processes every 4 seconds, and then it classifies them every 16 seconds, and it will change the CPU mode, or the CPU fan speed mode, every 16
And
seconds as
then
well.
I will start recording on this, and we're going to see once I type in the command. So right now it's in quiet mode. I'm about to set it to balance mode. It's all right. It's all right. And then we're going to set it to performance mode. Now it's kind of pretty loud. It gets louder as a CPU temperature is increased too.
Okay, so now that I'm sure that you, or at least I'm positive that you have a solid understanding of what I'm doing, what the product's all about, let's start getting into the project and just kind of showing you what it does. So the first step that you'll have to do to set it up is just calibrate it. So the calibration process usually consists of, or it actually just really does consist of, it warns you to turn off or to close all other processes that aren't usually active during idle. Then it waits a little bit to get some consistent temperatures. Then it records temperatures, and if it isn't able to get a consistent recording, then it will keep trying to record it again and again and again. It will run the stress test, so it will utilize 100% of all cores in your CPU for a good. We'll wait 30 seconds for the temperatures to rise in your CPU. Then we'll check and make sure that temperatures are consistent again, and then we'll try to get another consistent reading. This time, a stress reading, or a reading while your system's under stress. Um, and so to go with that idle reading, it will use these as boundaries. So the idle reading will be the lower boundary, and the stress reading will be the upper boundary for to like kind of sense when to know when to go when it's safe to go into quiet mode, when it's around idle, and when it's safe to or when it has to go into performance mode when it is around that stress temperature. So without further ado, let's get started. So as I said before, I just put my fan speed at normal mode, and it gives me all these warnings and tells me to close all my programs out that I don't normally run. PyCharm and OBX or OBS Studio is still open, so it might give it a little bit of an inaccurate reading. Sometimes it usually on my computer it usually does 68 degrees Fahrenheit or 70 degrees Fahrenheit for each of the recordings or for the idle recording. And I apologize, this voiceover isn't exactly on par. Um, what had happened with my original recordings was I had figured out my audio was fluctuating as I was trying to edit the video, so I had to record everything all over again. So as you can see right now, it's just waiting until processor temperatures are consistent. The method that it uses to do this is it records temperatures. So when it records one temperature or gets one value for recording, it takes 4 seconds. Um, it takes um, it takes values from each second, so 4 values, and then it makes sure the average difference of them, or like the range of those values, is within 8 degrees Fahrenheit. And then it takes the average of all of them if the range is less than 8 degrees Fahrenheit. Um, so now that my temperatures are consistent, it's taking measurements, and it will take as many attempts as it needs, and there's no real cap on how many attempts it will run. So now that the temperatures were consistent, actually on the first try, usually sometimes it can take around 6 tries or 7 tries for it to get through. Um, yeah, I probably should put in the estimate for how much time it's going to take. But now, so it's running the stress test on all 8 processors. You can see at the bottom right on my taskbar, my CPU utilization is at 100%. So it's going to wait 30 seconds, like I said before, for processor temperatures to rise, and then it'll wait until they're consistent. Um, so just to make sure that they're not rising anymore. When taking a measurement for the idle temperature or the stress temperature, it uses a span of um, 10 temperature measurements, or 10, yeah, temperature measurements. So it records temperature measurements 10 times. Um, and then if the range of those 10 numbers are within 8 degrees, then it will take the average of it. Yeah. So once it's done taking the temperature measurements, this is a really small bug. I have it to kill and terminate the processes for stress, but it doesn't happen. I'm not sure why. I've tried different methods of doing it. So you have to go into the process or the system monitor to turn everything off, or to close all the stress programs and stress processes. But yeah. It actually tells you it may be best to check if stress is still running as a separate process. Afterwards, after everything's completed, after it's taken all its measurements, and after it's closed, it will try and make sure that temperatures are reaching back to that idle temperature. So the recorded value that it took before, so in this case it was 71 degrees Fahrenheit. And so you can see once it gets a CPU temperature recording of less than 71 degrees Fahrenheit, which I think is going to happen pretty soon here, um, it will wait a little bit till it gets a consistent reading again, and then it will start the learning process. So we'll just start running the program like normally. We're taking a recording values or recording measurements every 4 seconds, and then every 16 seconds it will run the classification utility and set the CPU fan speed, and yeah, so it'll just run like normal. So it should take, um, when learning, what I usually found is that um, it takes like around 3 minutes for you to actually get like a baseline measurement for a program. So in the beginning of the learning process, you kind of want to run your program separately so it gets an accurate recording for each program or for each application or each process in that matter. So each process is kind of isolated. In the beginning, where it usually doesn't have too much data about the processes. Because if you run processes at the same time, one process may be contributing towards the higher temperatures, and one process might not be, but yet it will still record the same temperature for both of the processes. So now it's been around 3 minutes, or at least over 3 minutes. It's at least been 3 minutes. The reason why I say that is because the program usually measures the temperatures for an application once or a process once it starts up for 3 minutes after its starting time. So this is to better isolate the programs as I discussed earlier. Um, so we'll just run the Geekbench tool, and you'll be able to see that the application will change the modes for the CPU fans. Once the tool is being run, it'll actually say what processes are responsible for causing it, for what processes it thinks are responsible for the high CPU temperatures. So while this is running, I just wanted to explain further what the application actually does as far as learning. So every 4 seconds, it gets a new recording for process temperatures, and then so every 16 seconds or every on the fourth recording, it will classify all those processes. So it kind of compiles a big database of every process that's kind of been running on your computer, and so then it sums every temperature recording, every CPU usage recording, and every and it keeps account of all the sums of each recording, and then it takes the averages of the CPU utilization and the CPU temperature, and it plots them on the graph. Then it figures out the best fit line or the trend line of the graph, and it uses that trend line to translate sort of CPU usage to a temperature. And then once it's able to do that, the classification mechanism just uses the formula for the trend line, and it plugs in the CPU usage that's currently on a process, and it's being CPU usage on a live process, and it's able to map CPU usage to an approximate temperature value. And if that temperature value is anywhere between 15% and around 12% of the idle temperature and 15% of the stress temperature, then it will kick it into either performance or quiet mode, depending on if it's idle temperature or if it's stress temperature. Um, and then if it's in between those two boundaries, then it will kick it into balance mode. And yeah, so that's kind of just how the program works as far as identifying what mode to go into. Um, for my usage, I've used it for the past day, and I actually have one that will probably kick in a little bit earlier here for the past day. Um, like that will kick into balance mode a little bit earlier. Um, and it's been working pretty well. I haven't had any issues even when I try new apps or new games, then it'll kick in pretty soon, and it'll be able to kind of detect that it's something that's going to be um, utilizing the CPU a lot. So this is the perfect example of a bug that I've been running into. So sometimes, or a lot of the time actually, when you are running a bigger program, there are other processes like called worker processes that kick in as soon as the application starts. So these processes can't really be or aren't really made independently of the other processes. So they are a little related, and the algorithm, although there's only one process really causing this to be to causing it to go under balance mode or performance mode, which is Geekbench. It gives like a whole list of worker processes and other processes that occurred around the same time or started around the same time. This does clear up over time, and usually I'll get like one or two extra little processes in there when I with like my algorithm that or with my program that has been trained for a day. But yeah. So another thing I wanted to point out was once the Geekbench finished, um, it immediately went back to quiet mode. So it did detect that Geekbench was kind of like the root of the process, the root of the cause of why the temperatures are high. So anyways, that's my project, the Corsair Liquid CPU automated controller or automated Corsair Liquid CPU controller, cooler controller. A lot of words. Um, and hopefully it gives you like a good understanding of it and how it works, how the classification mechanism works, how the calibration mechanism works. So I would like to state that a lot of the functionality actually comes from I used SQL Alchemy to put it into a database, and I used Open Corsair Link to be able to connect to all the devices. That's what you see in the command line when you see the switching modes. Um, and I'd used stress to stress test it, and I also used another Python library called psutil to get all the CPU information and the the CPU temperatures and utilization information. Thanks for watching.